Welcome to the TTS Talking Educators podcast. Each week we'll be joined by educational experts from across the globe, offering exclusive insights, inspiration and guidance to help practitioners unlock the potential for learning in educational settings. Hello, my name is Dr. Shaddai Tembo, your host for this week's TTS Talking Educators podcast. I'm a senior lecturer at Bath Spa University, an associate lecturer at the Open University, and I'm just going to start that again, sorry. Hello, my name is Dr. Shaddai Tembo, your host for this week's TTS Talking Educators podcast. I'm a senior lecturer at Bath Spa University, an associate lecturer at the Open University, and an independent writer, speaker and consultant with critical early years. Throughout this series, we'll be discussing a range of topics aimed at supporting Oracy in primary and early years settings, inspiring you with guidance and resources to enhance your practice. I'm delighted to introduce Rob Jennings as today's guest. Welcome to the podcast, Rob. How are you today?
I'm good, thank you very much. I'm really fortunate to be invited. Thank you.
Brilliant. And before we get into our fourth and final discussion, perhaps you could just give a quick introduction to yourself for our listeners.
So I've been teaching people with maths difficulties and Dyscalculia for the last 15 years. And I'm a co-founder of the Dyscalculia network, which helps to sort of empower and support people that struggle with maths.
Brilliant. So we've covered a range of different topics over the previous 3 episodes, all around dyscalculia. And in this episode, the intention is to focus a little bit more on differentiation, multimodal inputs, but also more broadly how we might shift the narrative around dyscalculia in the future. We'll begin by differentiation then. Perhaps you could just explain that term for people who are unfamiliar with it, and then what does that look like in practice?
So in Oracy, maths encourage differentiation is to sort of allow the people that really struggle with maths to be able to give them the right support. And I think kind of the earliest thing to do with creating that differentiation is what we call an assessment, to be able to sort of spot, first of all, when things are starting to go wrong. And then the assessment and leads to hopefully a diagnosis. Even if it doesn't lead to diagnosis, it will a proper assessment will allow us to see what the strengths and weaknesses are, and to be able to put a focused teaching intervention plan in place to support that individual. So that differentiation is really quite important. It starts from really early on. We understand that it's difficult to kind of, is that maths? Is there something wrong with the maths or not? So we've developed this, we call it a checklist. And it's not a diagnostic tool in any way, shape or form, but it really does provide us with the opportunity to see what's going wrong with the individual and focus the mind really in terms of that. So we have a checklist on the website. And it's really simple to use. It has all of the indicators of dyscalculia and maths difficulty. But it's a really simple system in terms of we have red, do they exhibit that behaviour all the time? Is it amber sometimes, or green not at all? And it does really focus the mind in terms of developing that profile of the individual of observed responses. Sometimes it's difficult to just really start that sort of ball rolling in terms of gathering evidence about the individual's ability in maths.
So that checklist feels like a really useful initial tool just to begin to gather some broad understanding of where the child's at and what strategies you might put in place to support them going forward.
Yeah, it's a free download from the website, so please help. And it's been downloaded already thousands and thousands of times already.
Great. And it sounds like it's making an impact then, which is brilliant to hear. You mentioned the need for this to start early, so I'm wondering where early intervention sits within this discussion.
Yeah, I think kind of early intervention is quite significant because it gives the best chance to be able to support someone in terms of their math development. And the earlier we can get to sort of working on the things like number sense is really quite important. We, Kat Edel and I at the Dyscalculia Network, we view maths learning as a kind of equivalent to that. The analogy is the Jenga tower, that game where you take bricks out. So if you can imagine how that tower looks, and as we develop maths in the classroom, it's a very modular topic, and we take bricks off and we're putting them on top, and as you're developing along, but we're saying that our dyscalculic learners, or people that really struggle, have bricks missing in the key foundation areas. And if we're doing, as we're going along in year 7, year 8, as we're getting higher up in our mathematical education, the whole tower is becoming really more unstable. And even when we're lucky enough in schools to have intervention, it's often directed at the wrong place. We have someone struggling with fractions, for example, and they're lucky enough to have intervention, they have more of the same. Whereas we're saying, we need to look at the root causes of why they can't do fractions rather than just more of the same. And it might be that they can't multiply or divide fractions to find equivalent fractions. So when you have different fractions with different denominators, the number at the bottom doesn't really mean anything to them without doing that. So that division and multiplication are the real root causes. And they're the bricks missing that we have to sort of put back in place. And if you think about the Jenga analogy for how maths works, really important that the assessment is done properly to sort of really look at all of those key foundation areas. Can they write numbers? Can they read numbers? Do they understand what number sense means? All of those areas about sequencing, some subitizing in younger children. So really, even for older children and adults, we have to look at that key foundational areas of maths to be able to help them. Because you use those basic skills in whatever maths you're doing.
Yeah, I really like that analogy. Thinking about the interventions you mentioned, it probably is quite easy for teachers to get stuck in the same ways of trying to fix things, but actually going back to those foundations and those core concepts is probably a more effective long-term strategy.
When we talked at the beginning about kind of how maths is perceived as a general topic compared to literacy, if you have you're diagnosed with dyslexia, with phonological difficulties, you're taken right back to look at those the phonemes and how you differentiate between these sounds. Whereas we don't do that in maths. We haven't developed that kind of alternate learning paths readily. If you're sort of struggling to read, you have an aspect of, let's do more, let's have some practice, and over time you're going to get better at reading. Whereas in maths, it doesn't work like that. Without the fundamental building blocks in that key Jenga tower thing, you're not going to be able to do missing angles in geometry or things like that, because you're missing those building blocks. So you might do loads more geometry questions, and that's what often you're given worksheets to do a whole load of questions. You can't access those, so they become really difficult. So you need that sort of feel further back. And that's where the level of the quality of the assessment is really important, to be able to help find those missing bricks.
I also wonder if there's something about allowing children to input and express their understanding of maths in other ways beyond the spoken words. So thinking more multimodally about those different opportunities we can use to allow children to express mathematical understanding.
And, as I said in the other episodes, concrete materials are really important. And I think often we go too fast because of the size of the syllabus, but using maths is quite abstract, and I have so many different materials to use to sort of demonstrate things. Even for secondary school, we use kind of pegboards to show reflections and how to create linear lines and stuff. So we do use them across the board. And just the fact that, I use lots of Lego bricks for early years, where we're sort of showing what can break numbers up, what numbers are made of. That sort of, it's really good fun. We use Cuisinart rods, for example, to make number components. So we call them rod sandwiches. So we use a 5 and a 5, and then we fill up the filling with what makes 5. So you can prove it that it's 4 and a 1, 3 and a 2, it makes 5. And that's sort of working on developing mathematical fluency to be understanding what they're made of. And you can use them for addition and subtraction as a way of doing it rather than counting ones. A typical dyscalculic will often have sort of go-to strategies, and they'll be counting in ones. You often see people, if you have a 8 plus 5 as a calculation to do, you can't readily say, just start with the larger number and then add on. But often you might have a dyscalculic that goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And that's their go-to strategy, counting in ones. And they have this kind of, especially if you're older people and adults, they have this kind of way of masking it. So they become really good at counting. And so they can do it really quickly. Oh, I've got 13, no problem. But it really masks the techniques. They've not developed that in any way, shape, or form. And we also see things like 8 plus 5 put into columns. So, because that's their go-to strategy, that they don't really understand why I'm doing it, and it's not going to help them in any way, shape, or form. But putting it into columns, one on top of the other, is their way of sort of dealing with that, because they don't really have a level of understanding about the maths involved. So using concrete materials is really, you can prove it. That's why we're using it. And you can develop strategies like 8 plus 2 using number bonds, plus 3. And that's sort of, bridging. And those sort of things are really good and easy to demonstrate, and are really good techniques to be able to help people.
It's really helpful. Thanks for sharing that. I'm mindful that we've predominantly spoken about the challenges around dyscalculia. Therefore, I'm interested in the research around what the strengths are in terms of how people with dyscalculia process things differently. What does it say about that?
Yeah, I think kind of dyscalculic people are really quite, they think of the bigger picture. So their understanding of what goes on and ability to solve problems, often non-mathematical problems, but really kind of understand things much more to enable that to solve that problem. It depends on the co-occurrence with other neurodiversities on that, but also they tend to sort of move towards the more creative industries, and to be much more creative in terms of the visual arts, for example, in terms of reading, understanding, comprehending different things that's going on. They pick things up really quickly. Yeah, I mean, they're fantastic, really, as individuals moving forward.
Yeah, absolutely. We're just coming to the end of this podcast now, Rob, so I'm interested in your long-term vision. What would you like to see from your Dyscalculia network? What would you like to see different in society as a result of the work you're doing in the next few years? It's a big question, but I'm interested.
It is a big question. How long we got? But I'll be as quick as I can. So I want people to understand that dyscalculia is quite debilitating. I want to understand that these people that struggle with maths, there is a way forward in terms of helping these people. And it's not just individual about can you do maths. It really does impact on their mental health. Because if you can't do maths, you live your whole life thinking, I'm stupid, I'm dumb. But it's just it's a neuro impairment, if you like, of not being able to do maths. And I think kind of changing that attitude is really important. The understanding, the diagnosis and support for adults is really needed, and moving forward is really important. Because in the UK, our levels of adult education is awful, and it's even worse than in schools in terms of support. There used to be lots of adult education opportunities. There's much less now. And we've been working with a lot of kind of these organisations to provide the support. It should be much more widespread. We are quite fortunate that we have a number of peers from the House of Lords that are supporting us, and they have secured a debate in the House of Lords on June the 4th about dyscalculia. So we're delighted about that. They're also the Department of Education have allowed us to have a roundtable talking about dyscalculia and how we can change what's going on in the education system and outside. And so that's taking place on Friday this week. So, we're trying to do all we can to raise awareness so that we can put in place the right levels of training for our teachers of the future and support them as well, because the commitment and the passion's there. It's just being able to help them, provide them with the right information and training to be able to support the dyscalculics of the future.
You hopeful?
Yes. Yeah. I mean, if you think about the Dyscalculia network, it wasn't there 4.5 years ago. It is now, and we're not going to go away. So we're going to make that change and make it change for the better.
I'm hearing there's lots of work to be done around the PR of maths, perhaps potentially making it a bit cooler, but also paying attention more seriously to those systems that are in place throughout society. And adult education is a real piece of that puzzle, isn't it?
I think also just making sure that we make maths relevant. So much maths goes on that you don't even realise you're doing it in our everyday lives. We just make it tuned into what people kind of see as important to them in the future. Bank accounts, how to handle finances, those sort of things, timetabling. Really things that's going to be of benefit to people in the future and help them. Maybe less, if you want to study further maths in terms of more abstract calculus, then that's great. But for the general people, less algebra might be a positive thing moving forward.
Yeah, it's a really interesting place to end this episode. Thanks so much, Bob. Let's hopefully make maths more relevant in the future. It's been brilliant to speak with you, and I look forward to following the developments of your work over the next few years. So thanks so much.
You're welcome.
I would like to say a huge thank you to our guest, Rob, for joining us and providing such valuable insights. You've been listening to the TTS Talking Educators podcast with me, Dr. Shaddai Tembo, and Rob Jennings. If you've been inspired by our conversation today, don't forget you can sign up via the link in our episode notes to be the first to hear about future episodes and access exclusive follow-up content, including ideas for your setting and links to relevant resources.